Hi! So you may or may not know I'm fairly established in the competitive programming world. Here's a list of stuff I've gotten. But I have basically zero experience with actual coding interview stuff. So the question this video will try to answer is competitive programming alone enough to get good at coding interviews, or are they completely different games? And I can see some obvious similarities. In both cases, you have technical problems that are solved by writing a program to accomplish some task, but there are also some obvious differences. For example, in competitive programming, your only goal is to get a working program as fast as possible. But in coding interviews, you're aiming for the most efficient solution complexity-wise, not just any solution that fits the constraints. And you also have to understand your solution well enough to explain it to the interviewer. There's a fair amount of differences. And I kind of know already that I have the weakness of getting stuck on a complicated solution and missing out on a simpler one, which is pretty bad for the coding interview stuff. So that may screw me over too, but I will try to be careful about it. But okay, I'll shut up now and we'll just get into the experiment. Okay, wait, maybe I can't shut up just yet because I still have to explain the format, but luckily it's pretty simple. I'll pull 4 questions, one for each FAANG company from LeetCode. Hard difficulty, of course. And I said 4 because Netflix is different and doesn't really ask LeetCode stuff, so I'm just going to leave that out. And we're just going to do each one. I'll show you the whole process from start to finish. And at the end of each one, I'll do a recap of how the question went in terms of time taken, other interview-specific stuff like more efficient solutions that I may have missed. And there are timestamps in the description, so you can jump around to these if you want. And one more thing, feel free to try each question yourself, but I'm not going to make the effort to go over my own full solutions here because it's not really relevant to the point of the video. But if this video gets me over 1,000 new subscribers, yeah, we're doing subs because they're better than likes, then I'll post a separate video that goes over my solutions to all of these questions as a bonus. So hit that button. That is all. For real now, let's start. Alright, this is the Facebook one, and I have nothing more to say, so let's just get started. Okay, so you have a binary matrix grid, okay, and you can, change 0 to 1. So, let's see, so looking at these samples, 1, 0, 0, 1, yep, 1, 1, 0, okay, and it's up to 500, so we need, okay, I see. Interesting. So yeah, n by n, okay. Alright, so initially we were thinking just, if we try changing each cell, how do we efficiently check if things are connected or not? If we change a cell, then, yeah, if we change a cell, we want to see, is left and up connected? Is left and right connected, and is left and down connected? And if so, what do we do? So if we can check that, that would make things very easy. If we could just efficiently check if the 4 sides are connected to each other. Okay, so we can mark each element in grid with its component. Okay. So we find components using DFS or something. Then we start off by just making G global. Does this actually work? I'm not sure if this works. Okay, so we're gonna DFS. And then once we DFS, we check components. Wait, why is this? This shouldn't be Java. Oh yeah, that would mess things up. Okay. Okay. Alright, that's fine. We didn't actually write any stuff yet, so that's good. Yeah, so we're in C++. So G equals grid. That way we can do global. And we need to run DFS. So once we do DFS, then we just need to... Okay. Actually, no. No, wait. N equals grid.size. So make a component, make a array of components, don't save. I'm gonna do that so often. Make an array of components, start off with -1, meaning that initially everything is not part of a component. Then by the way, I'm not necessarily trying to explain my solution. If I was, I'd be drawing stuff out. But right now, since this is just sort of more of a test, I'm just going to try and solve. Gij is equal to 1, and components -1, meaning we haven't visited this yet. DFS ij C++. Okay, so components. We're just going to keep track of sizes, so I'm not sure if they already do this, but whatever, because they don't have std vector. I guess it's whatever. So ants equals max, ants size C. No, wait. Okay. If let's make this a function. So if valid nr DFS should be good. Okay, now what we need to do is for each cell, try and change it to 1. So if grid ij 0, then okay, we need to do this like efficiently somehow. Actually, it doesn't really matter. I mean, okay, this is kind of annoying because I want to like get rid of duplicates, but in such a way that like the cleanest way to do this, I guess, is with a hash table, but sorting is easier, so I'm just gonna do that. Wait, did I screw this up? No, okay. If valid ni and j and grid g and I and j is equal to 1, comps dot push back components ni and j. Okay. Guess we don't really need a hash map, we can just do this. So for if not this x, and we total the sizes. All right, I'm going to reset visited. All right, there we go. So initially let's just try it. See if it works. Yeah, don't put a semicolon there. All right. Yep, I've done C++. I know C++ very well. Very, very well. Okay, come on. Stop with the compile errors. This is dumb. Oh, +1. Because we changed this to 1. So there we go. Okay. Let's just see if it works for everything. All right, do a quick run through of the code just to make sure. So for each thing, if it's 1 and components is -1, components is that, add to the size. For each direction we can go in, if valid and that is 1 and this components is -1, then DFS that new place. Yep. And for each thing, if it's valid and grid is 1, yep. So total is 1 for index comps if this x, not this x. Yeah. Okay, let's try it. Nice, all right. Okay, considering that this was basically my first serious interview question ever, and also my first time doing competitive programming for a while, this was a pretty good result. I'm almost certain that this is the optimal complexity since it's O of n squared time in memory, which is the size of the input, and you can't really do better than that, but yeah. But I will admit, this one was a bit unfair since I've done so many competitive programming problems on stuff like DFS and BFS and grids and flood fill in general. So this question was basically second nature, and I already knew how to do a lot of the stuff. But the later questions are stuff that appears more in interviews than competitive programming, so I end up more out of my element. And I'll also say that I was a bit tripped up near the beginning, just like I tripped up on that word, since I was having some PTSD from some harder problems, and I thought I had to like dynamically figure out which components were which. But it turns out that the pre-computation worked out just fine, so no PTSD necessary. And that's all for this one. Overall, it went pretty well, so on to the next one. All right. Now we're on to Apple. Yeah, let's go. You're given an array of k linked lists. Each linked list is sorted in ascending order, and your goal is to merge all the linked lists into one sorted linked list and return it. Okay, got it. Okay, so we get a public struct, so that's fine. Okay. All right. So let's see. So we could use a priority queue. Yeah, we could use a priority queue. What? Oh, empty list and then list of an empty list. Okay. All right. So we could use a priority queue. Can we do better? Priority queue is in total, if there are n elements in total, it's n log k. Which I don't think we can do better than, but I mean, can we? Like, can we do better than that? Because if not, then I'm just gonna code this, but yeah, okay. Like this should be, yeah. I'm taking my time here because again, I know that I get stuck in complicated stuff, and I don't want to do that. But I mean, priority queue is really simple. I mean, yeah, that's basically it. Okay, cool. Okay, null pointer. This should return, if it's empty, it should return null. Yeah, null pointer. Okay. List node cur is equal to null pointer as well. Cur is going to be the back, and is going to be the start since we need to return the back, or return the start. So priority queue. I'm assuming if we get a compiler or whatever. So right now we want this to be sorted in, we want the priority queue to return the smallest element. So we need to use greater than to reverse the effect. And what we're going to do is for list node x lists, x not equal to null pointer, then pq.push a pair of x's value. No, we need this to be an int array. Lists I, x is not equal to null pointer, pq.push x val, and the second thing is the index because we need to do that. So while not pq.empty, pq.top, pq.pop. So if ants is equal to null pointer, no wait, so cur is equal to list node, and is equal to new list node with x's value, x dot first, not f, I don't have my templates. So if ants is equal to null pointer, ants is equal to n, cur is equal to n as well, else cur next is equal to n, because we need to link the list together, and cur is equal to n because now n is the back element. Now, if lists, wait, no. Okay, we need to advance lists x dot second is equal to lists x dot second next if is equal to null, not equal to null pointer, then add the element in the priority queue. pq.push lists x dot second value and x dot second. There we go. Return ants. All right, let's see if this works. I have no idea. Size. Again, it's been a while since I've used C++ actually, so I'm a bit rusty, but okay. Let's use all the example tests. Okay. Nice. All right, this is just work. I mean, I don't see why this wouldn't work. Nice. Pretty good runtime too. I don't know how, why is the memory usage? Oh, well, probably the priority queue. Okay, whatever. So unlike the previous question, this one was pretty new to me. Because in competitive programming, you very rarely deal with stuff like pointers or linked lists or even just this type of input format in general. In competitive programming, you just get these lists as text as part of the input, and you would have to store them internally in something like a list of lists. And because I wasn't used to this type of input, my space complexity or my memory usage was pretty bad compared to a lot of other people. And this is because there's another solution that I didn't find, namely merge sort, which is in place and thus uses O of 1 extra memory, but has the same time complexity, so it's just a strictly better solution. Because in competitive programming, the elements of the array, or of the arrays, would count towards your memory usage no matter what, because you have to do input and output, and you have to output the array. But in this question, because you were given a list of pointers, it didn't cost any extra memory to just move those pointers around, so an in-place solution would actually be true O of 1 memory. So ultimately, I missed out on a memory efficient solution because of my lack of experience. So I can't call this a complete success, but I did finish my solution pretty quickly, so I might have had enough time during an actual interview to keep going after like some warning or guidance or something and find the better solution. So my competitive programming skills did help a good amount for this one, but not enough for a perfect result. And anyway, on to the next question. All right, question number 3. This one is from Amazon. And yeah, let's get started. Okay, given a integer n, ooh, this has a lot of dislikes, interesting. Given an integer n, return the number of ways you can write n as the sum of consecutive positive integers. Consecutive, okay. 10 to the 9th, okay. So we can iterate over the number of integers. Okay, so I can do this in square root n. But essentially, we're looking for the number of x, so that for x, if we use x positive integers, then the sum will be x times x plus 1 over 2. That's like 1, 2, 3 up to x. I'm doing this math out in comments because I don't have a whiteboard with me. So yeah. That's not a minus, that's a colon. Right, and then okay, so then the condition that needs to be satisfied is n minus this quantity mod x is equal to 0. Right. Because we can shift this value up, like we can do 2 to x plus 1, and that in total will add x to the sum. So as long as, and also n has to be greater than or equal, obviously, because otherwise it would be too big. So of the x where this is true, do that. So the thing is, for odd values, this is for odd values, x is divisible by that. X is divisible by this. So for odd values, this doesn't matter. For even values, of x, okay, I don't see a better way. Because even if we relate this to the number of divisors, which is not necessarily the case, then it just doesn't work. Yeah, even if we do the number of divisors, it doesn't work. So let's just iterate over x. So int count ants equals 0, for int x equals 1, x times x plus 1 over 2. Okay, by the way, this could have gone much faster, but I'm just making sure that I'm not missing something simpler, because I want to do this right. No, x is less than or equal to n. If n minus v mod x equal to 0 plus ants. Okay. I'm used to my templates. 1, 2, 3. Y. 5. What's happening here? Okay, so n minus v. Oh, do not do that twice. That's why. Because n minus v. Yeah. Pretty sure that just checks if it's n. Because n minus that is just that. So that, yeah, okay. I'm pretty sure this works though. Yeah, nice. Alright. Overall, I don't have much to say about this one. This was a really good time, and looking at the discussion, I'm pretty sure you can't do better than O of square root n, and my memory usage is just O of 1, so I think my solution is optimal. Ultimately, it was a math problem, and Codeforces has a lot of those, so I had a lot of experience with math already. That's probably also why the like to dislike ratio is so bad with this one. But that meant it was easy to code and easy to think of, so I have no complaints. On to the final question. All right, final question. This is from Google, and this has a long statement, so this will be fun. All right, from some starting index, you can make a series of jumps. First are called odd, so odd jumps are odd, even jumps are even. Jumps are numbered, not the indices. During odd numbered jumps, you jump to the index j, such that Ri is less than or equal. Yeah, so Ri is... What? You jump to the index j. So you jump to the smallest value to the right. During even number, you jump to the largest value to the left. Wait, no, sorry. No, yeah, okay. You jump to the... Okay, I'm reading this wrong. So you jump forward to the smallest value that's bigger than Ri. And during even number jumps, you jump forward to the biggest number that's less. Okay. Starting index is good. If starting from the index, you can reach the end of the array. Okay, so thinking immediately DP, because once you get to an index, you don't care how you got there. All you care about is whether you're at odd or even. So that lends itself nicely to DP because, yeah. Okay. So the only thing that's left is how do we find, for each index we need to find where we go. For each index we need to find where we go for odd, where we go for even. So let's store two sets, one for positive values, one for negative, and okay. Okay, int n equals r dot size equals vector int n vector int 2 0. Rather Boolean, I guess. Yeah, sure. So for 10, okay, set pair int odd set pair. Let's let's just do 2 even. Now, so dpm minus 1, 0 is equal to d1, dpm minus 1, 1 is equal to 1, because we can automatically get there. So plus equals dpm minus 1, 0. No, dpi 0, because because we can only get to the end if we can start here at an odd jump. Cool. So now we need to test out the, so let's handle odd. We need lower bound. Yeah. I. If it is not equal to odd.end, dpi 0 is equal to dpi 0 or dpit first 1, because now that's even. Odd.insert ri I. Okay, so yeah, that will find the lowest and the smallest index by default. So auto it is equal to even dot lower bound negative rii. Still lower bound. It's negative because now we're going for values that are smaller. So if we're going for 4, then we want 3. Negative 4 is less than negative 3. Yeah. And we still have the index be that. So if it is not equal to even.end. Although I think this is the best we can do, because I don't know, maybe okay, wait. Maybe I'm jumping too far into it. Theoretically, we could do this with could we? No, we need every single value. Yeah. Wait, do we? Yeah, I'm pretty sure we can't do this with like monotonic stack, right? Because we need every single value. We need every single value because larger values are more useful but less desirable. And we want smaller values because they're, yeah, we need to keep every value, pretty much. The only values we can get rid of are duplicates, but yeah. So that should be, yeah, okay. dpi1 equal to dpi1 or dpit first 0. Okay. Compilation error, I assume. Yeah. Runtime error. Okay. That's a useful thing. So n equals r dot size. Oh, I'm not. Yeah, no, wait. What? That shouldn't make a difference. Auto it equals odd dot lower bound if it is not equal to odd dot end. Yeah, shouldn't make a difference. It should still crash, I think. Yeah. So why? Because this should be the second. Yep. Because we're looking for index, not value. So that would go out of bounds. Perfect. Use examples. Should all work, I assume. Oh, cool. I didn't know that did a LeetCode thing. This is taking a while, but yeah, okay. So this should just work. So I'm pretty sure this is optimal. I don't know how we would do better because, nice. Okay, that's pretty slow. Okay, this one was pretty mixed. The time was okay, second worst, and I had a little brain typo that caused me to get a runtime error, but ultimately it was a pretty smooth solving process. The solution, however, was not that smooth because I noted at the end that the runtime was really bad comparatively. And the reason for this is that std set is extremely slow. And I did know that going into the question, but I didn't know how others were managing to avoid it. And it turns out, after looking at the discussion section, my time complexity of O of n log n was actually optimal. But the way to avoid using set is just to sort the array. Because on the sorted array, the task of figuring out where the jumps go just turns into the standard nearest greater element, since you're looking for the element with the smallest index to the right that's greater than your current value. And the n log n from sorting is much faster than the n log n with set, so you end up with a much faster solution, and also better memory since set just sucks overall. But unlike the Apple question where my entire complexity wasn't optimal, I still had the optimal time and space complexity for this question, it just wasn't as fast as it could have been. So this wasn't completely bad, but it also wasn't completely great either since my constant factor was bad. But anyway, on to the conclusion. So overall, I would say the whole thing went pretty smoothly, kind of as expected. And there were a couple of hiccups where I ended up with a solution that wasn't completely optimal, but overall it was pretty good. And I say it was pretty good because hopefully in an actual interview there would be a bit of a warning that what I'm doing isn't completely optimal and I should look for something better. And since I was pretty fast on each one, I wouldn't have enough time to find the actual optimal solutions. And the time per question was very good, especially since I hear the typical length of these coding interview rounds is like 45 minutes. So even when considering the time for like explaining my solution and stuff like that and thought process stuff, I would still have a lot of time left over. And honestly, it really did go as expected. My competitive programming skills helped me figure out my solutions really quickly, but my lack of interview experience led me to miss out on some better solutions because I wasn't really experienced with searching for the optimal solution, since again, the goal of competitive programming is just to get a working program as fast as possible. So I guess the answer to the overall question is both. Competitive programming and coding interviews are pretty related in terms of the questions you'll be tasked with solving, but they're also fairly different games because interviews also take stuff like optimization into account, and also you have to spend time explaining your solution, which I did not do because I didn't want to. And honestly, if you're wondering what to do for yourself, I would just say to take the common sense approach. Practice what you're trying to get good at. If your sole goal is to get good at coding interviews, practice coding interviews, or with competitive programming, vice versa. Don't waste time doing something else that's only like marginally related. Practice what you're trying to get good at. And yeah, that's about it, because this was just a random experiment that I wanted to try, and since I haven't uploaded a screencast in a while, I figured I would give you guys something similar to a screencast, but also more related to my future plans for my channel. And yeah, so that's what this was. And goodbye.